All right, this is going to be a quick tutorial on how to draw pictures of atoms, specifically when you're using that weird shell 3 rule. So remember, our 3 rules are our rules for building the shells. In shell 1, you can have a maximum of 2 electrons. In shell 2, you can have a maximum of 8 electrons. So it doesn't mean you're always going to have 8. It means you can have up to 8. Before you need to start putting electrons in shell number 3. And you'll remember from your notes that shell 3 has a weird rule. So shell 3 says to add up to 8 electrons, then put 2 electrons in shell 4, then go back to 3, and add up to 18 electrons total, okay? So that feels like a lot, that feels overwhelming, but we're gonna go ahead and walk through an example of how you do that using this element right here, vanadium, which is number 23 in the periodic table. So we're gonna identify a couple things about each about the element before we start drawing it. So we have our symbol. It is number 23 on the periodic table. So we're going to identify 4 things. First of all, number 23 means that it has 23 protons. That also means that it has 23 electrons. So this is important because that tells us how many we need to put in the shells. We then want to identify 2 more things, the period and the group, okay? So, period refers to which row of the periodic table is this in. So it is in row 1, 2, 3, 4. So this is in period 4. It is also in group 1, 2, 3, 4, 5. One thing I want you to notice is that on this periodic table, I have also placed in parentheses an additional group number. This group number is really important because it actually tells you how many valence electrons there are supposed to be in your atom. And you'll notice there is no alternate labeling in the transition metals. That will be really important later, so hold on to that thought. Let's go back to vanadium, okay? 23 protons, period 4, group 5. So what do? First, we put our symbol and 23 protons. Now, it's in period 4, that means it has 4 shells. So we can go ahead and draw 1, 2, 3, 4. Okay, we have 4 shells, and we need to put electrons on those shells. The first 2 shells are super easy, 2 and 8. We have more than 10 electrons in this atom, therefore, we just go ahead and put those 10 on directly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need to get to 23. We are missing 13 of our electrons. So we're going to go ahead and start. Add 8 to shell 3. 1, 2, 3, 4, 5, 6, 7, 8. This right now has given us a total of 18 electrons. So now I'm going to take us back to the periodic table. The element that has 18 electrons is right here, argon. If we add more electrons to our atom, we are actually pushing ourselves to the next row or the next period in the periodic table, 19 and 20. But we know that if you have this many electrons, you should already be on the 4th shell. So here we have 2 electrons that don't belong on the 3rd shell. They belong on the 4th shell because they're in this row. So put 2 electrons in row or shell 4. So I'm going to put them up here. Now, how many electrons do we have left? We've got 20 so far. We need 23. but we don't want them to go here. We don't want them on that outer layer because our periodic table tells us that we're not supposed to have 3 valence or outer electrons until we get to this number here. So what do? We're gonna hide them in the 3rd shell. So what I'm gonna do is I'm gonna go back and I'm gonna put those extra 3, 1, 2, 3, into my 3rd shell. So basically what we're saying is anytime we have electrons that need to go to match anything in our transition metals, we actually want to make sure that it's going in the row below the outer one. Because the only time you should ever get to 3 valence electrons is when we're here. Vanadium is too early in the periodic table. So 1, 2, 3, 4, 5, 6, 7, 8, I counted wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those 10 need to be living in the row below the outer one. Otherwise, you're going to end up with too many valence electrons in your outer shell. So our final model for vanadium shows us as having 2 valence electrons and a total of 23 atoms. Okay? I'm going to go ahead and do one more. We're going to go ahead and I will do the model for bromine, number 35. I'm going to keep the rules here. Bromine is 35. So we have 35 protons, 35 electrons. It is still in period 4. It is in group 17 or 7A. So what does this tell us? This tells us the number of shells. This tells us the number of valence electrons. So now let's draw. Bromine, 35 protons. 4 shells. 1, 2, 3, 4. Okay. First shell, 1, 2. 8 in the second shell. 3, 4, 5, 6, 7, 8, 9, 10. 8 in the third shell. 11, 12, 13, 14, 15, 16, 17, 18. Pause. 19 and 20 go in the 4th shell. Now I can go back and add another 10 to the 3rd shell. So that would get me up to 30 because I have 20 right now. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. But bromium has 35 electrons, but we're out. We're out in shell 3. I already have 18 in there. So what am I going to do? I'm going to put the last 5, 31, 32, 33, 34, 35 in the outer shell. Now let's count the valence electrons. 1, 2, 3, 4, 5, 6, 7. Checks out. We have 7 valence electrons and a total of 35 in our atom. Feel free to email me if you have questions, but this is basically your steps for completing anything that is going to have 3 or 4 shells. We're never going to have to do anything with, 4 or 5 shells or 3, whatever. But we're never going to have to do anything with 6 and 7 because it gets really complicated with this extra layer. So concentrate on things up to number 54, 55 is about where you would need to be. All right. Good luck studying, and I'll see you in class.